Oh my gosh, this is so fancy.
Isn't it? It took 2 quarters for me to get here, but now I am fancy. So in this one, it wanted to know what the tension is on that line compared to that applied force. Let's see, what else are we told? We have an applied force is shown and it's accelerating to the right. So we have acceleration going that way. Okay. It says it's smooth, so there's no friction. Are you good with that?
Yeah.
Okay. So the trick with these, until you really develop intuition on it, get rid of that cord, is to do a free body diagram for both. So for P, let's see, what do I have? I have force of gravity straight down, which isn't very exciting because there's no friction. And the force normal, let's make sure we're clear about this. This is P. No friction, so nothing opposing the motion that way, and a force of tension then going that way. So it's the tension on that line that's accelerating that box P.
Yes.
So you go with that?
Yes.
Okay. So then if I do the same thing for Q, let's see, I have a force applied going that way. I have a force of tension resisting that motion. And then just kind of the force of gravity and the force normal. So what you said, and is absolutely correct, is they both have the same acceleration. Because if they didn't, then P would either be smacking into Q, or Q would be pulling away from P, snapping that line. So what do we know about the tension here?
That they're equal?
Yep. So A of P equals A of Q, and tension for P equals the tension for Q. So those things we know. So then I come down here, and I say, okay, so the force of tension here, if I do the sum of my X, and I'm not going to worry about my Y, we go like that is positive. And I go, so the force of tension is the only X component, and we're told that it's accelerating and accelerating to the right, so that equals massive P times acceleration. You go with that?
Yeah.
So I know that the acceleration is the same. I know the masses at least appear different. It says, okay, so it says the mass of P is greater than Q.
Yes.
So I'm like, okay, so this force of tension then is definitely a product of that mass and that acceleration. You go with that?
Yes.
Okay, so now let's do the sum over here. Let's see what we have. We have the force applied is to the right, and then minus the force of tension equals mass, I'm going to run out of room, Q times A. So I can do all sorts of different things with this, or for this question, this is really the only piece I need. Because if I wanted to solve numerically, what I could do is put this force of tension in terms of the mass P and its acceleration over here, and then go from there.
Okay.
But for this, it just wants us to relate what this tension is related to that applied force. So what if T were greater than the applied force? What direction would I be accelerating?
If tension were greater?
Yeah, if tension is greater than the applied force.
Then you would be going, would you be accelerating, or would you just not be moving? Or like, would you not be, or would it go with opposite?
I'm sorry. Let me turn you up a little bit because I'm having a hard time hearing. There we go. So what did you say?
I think I'm confused because if the tension is too much, then wouldn't it not be moving at all?
So what would the force of tension need to equal to either have constant velocity or stop the motion?
0? No?
I'm sorry. Well, now I forgot what question I asked you. What would the force of tension relative to the force applied need to be for this thing to be stopped or going at a constant velocity?
Do they have to be equal to each other?
Yeah.
Okay.
So if tension equals the force applied, then acceleration is 0.
Mm-hmm.
So I look at this and I'm like, well, I'm told that it's accelerating to the right. So this is wrong.
Yeah.
If the force of tension is greater, what does this negative sign tell us about the direction it would accelerate?
It would go in the opposite direction of.
Yeah. Then acceleration would be negative.
Okay, I see what it's asking now.
Yeah.
Okay, got you.
So the only way for this to be accelerating this way is if tension is less than the force applied. Then acceleration is positive.
Got you. Sweet. Thank you.
Okay. So what I suggest that you do until you get kind of more comfortable with these and can kind of visually reason it out is always do these.
Yeah.
And never ever let yourself put in like some fictitious force where you're like, well, so there must be something acting over this way. Right. And then doing the same kind of thing looking over here, I said the force of tension is going this way. Would it be possible to accelerate to the left with nothing acting to the left?
No. It wouldn't.
No. Yeah. So I could have even stopped there
Yeah.
and said, okay, so this has to be going to the right. And so then the only way to make this positive is for this to be smaller than my applied force.
Got you. Perfect. Sweet. Thank you.
You're welcome.